Welcome back to G Fun Facts Online. Today, we are taking a deep dive into one of the most remote and mysterious corners of our solar neighborhood. We are traveling nearly 3 billion kilometers away from the Sun, out to the realm of the ice giants, to talk about a world that has baffled scientists for nearly 40 years. We are looking at Miranda, the smallest and innermost of the 5 major moons of Uranus. For decades, this moon was written off as a geological accident, a frozen Frankenstein's monster that didn't make any sense. But thanks to a groundbreaking study released in late 2024, we now see Miranda in a completely different light. It turns out that beneath its scarred and chaotic surface, this tiny moon may be hiding a secret that redefines what we know about habitable environments in the cosmos. We are talking about a vast, liquid ocean. So let us set the scene. The year was 1986, specifically January 24th. NASA's Voyager 2 spacecraft was sweeping past Uranus. To this day, Voyager 2 remains the only human-made object to ever visit the 7th planet. The flyby was incredibly fast. The spacecraft had only a few hours to capture data on the entire Uranian system before sailing on into the void. But in that brief window, it snapped a series of images of Miranda that left planetary scientists scratching their heads. You have to understand what they expected to see versus what they actually saw. Miranda is small. It is only about 470 kilometers or 290 miles in diameter. In planetary science, the general rule is that small bodies cool down fast. Lacking the internal heat engine of a massive planet or a large moon, a body this size should have frozen solid billions of years ago. It should be a dead, cratered ice ball, much like Saturn's moon Mimas, which looks a bit like the Death Star but is geologically inactive. That is what the scientists expected. A static, frozen relic of the early solar system. Instead, the images Voyager beamed back revealed a world of violent contradictions. It looked as if Miranda had been smashed apart by a sledgehammer and then clumsily glued back together. The surface was a chaotic jumble. You had heavily cratered ancient highlands sitting right next to young, smooth plains, with no clear transition. There were massive fault canyons slicing through the crust, some of them 12 times deeper than the Grand Canyon. And then there were the coronae. These are 3 massive, oval-shaped features named Arden, Elsinore, and Inverness. They look like giant racetracks or fingerprints stamped onto the ice, consisting of vast systems of ridges and grooves. These weren't impact craters. They were something else entirely. For a long time, the leading theory was catastrophic disruption. The idea was that perhaps Miranda had been shattered by a massive impact in its past, and gravity had simply pulled the shards back together in a random, jumbled pile. That would explain the Frankenstein appearance. But the 2024 study, led by Caleb Strom of the University of North Dakota and Tom Nordheim of the Johns Hopkins Applied Physics Laboratory, offers a much more thrilling explanation. They suggest that Miranda was not broken from the outside, it was churning from the inside. This discovery didn't come from a new space mission, but from a forensic re-examination of that old Voyager data using modern computing power. The research team decided to reverse engineer the moon. They mapped the specific stress patterns on Miranda's surface, the cracks, the ridges, and the scarps, to figure out what kind of internal forces could create that specific geometry. They used a sophisticated computer simulation known as the 4-layer model. They tested various internal structures to see which one matched the surface reality. They simulated a solid ball of ice. They simulated a moon with a rocky core and a thick ice shell. And finally, they simulated a moon with a liquid ocean sandwiched between the core and the crust. The results were unambiguous. The only model that accurately predicted the placement and orientation of the surface cracks, specifically the trapezoidal shape of the coronae, was the one where Miranda possessed a thin, brittle ice shell overlying a deep, global ocean. The numbers behind this ocean are staggering. The model suggests the ocean likely extended at least 100 kilometers deep. Now, consider that Miranda's radius is only 235 kilometers. That means the ocean would have occupied nearly half of the Moon's total volume. The icy shell hiding this water was surprisingly thin, likely no more than 30 kilometers thick. This transforms our understanding of Miranda completely. It is not just a rock and ice body. It is a water world in the truest sense. It is essentially a drop of water encased in a thin shell of ice, orbiting in the deep freeze of the outer solar system. But this raises a massive question. How? How could such a tiny moon, so far from the Sun, keep a liquid ocean for hundreds of millions of years? The Sun out there is just a bright star. There is virtually no solar heat. The answer lies in gravity, specifically the complex gravitational dance of the Uranian system. Moons do not orbit in isolation. They tug on one another. The researchers identified that in the past, Miranda likely entered what is called a 5-to-3 mean motion resonance with its larger neighbor, the Moon Ariel. This is a very specific orbital configuration. It means that for every 5 orbits Miranda completed, Ariel completed exactly 3. This periodic alignment acted like a pump. The two moons pulled on each other rhythmically. Think of it like a parent pushing a child on a swing. If you push at the exact right moment, the swing goes higher. In this case, the resonance forced Miranda's orbit to become eccentric, or elliptical, rather than a perfect circle. Because the orbit was elliptical, Miranda was constantly moving closer to Uranus and then further away. As it moved closer, the giant planet's immense gravity stretched the Moon physically. As it moved away, the Moon relaxed. This constant stretching and squeezing is called tidal heating. It is the same principle as bending a paperclip back and forth. If you do it fast enough, the metal gets hot. Inside Miranda, this friction occurred deep within the rocky core and the icy mantle. It generated enough internal thermal energy to melt the ice from the inside out. This heat engine is what drove the formation of the ocean and powered the geological upheaval we see on the surface today. The rising plumes of warm water or slushy ice pushed up against the brittle crust, fracturing it to create those strange coronae. The ridges we see are essentially the stretch marks of a world that was expanding and churning from within. Let us take a closer look at those surface features with this new context. We can now read the surface of Miranda like a geological history book. The 3 coronae, Arden, Elsinore, and Inverness, are likely the smoking guns of cryovolcanism or ice volcanoes, and diaparism, which is the upwelling of material. Take the Inverness corona, located near the South Pole. It is nicknamed the chevron because of its bright V-shaped checkmark. It is likely the youngest of the 3. It formed when a plume of warm slush rose toward the surface, but didn't quite break through, causing the crust to buckle and crack above it. Then, look at Arden and Elsinore. These are massive features spanning hundreds of kilometers. Their concentric ridges suggest the surface was pulled apart as the underlying ocean churned. These are tectonic scars where the skin of the Moon was stretched to its breaking point. And we cannot talk about Miranda without mentioning Verona Rupes. This is the most famous feature on the Moon, and for good reason. It is a cliff face that defies imagination. It rises 20 kilometers or 12 miles above the surrounding terrain. That makes it the tallest cliff in the entire solar system. To put that in perspective, Mount Everest is about 8.8 kilometers high. This cliff is more than double the height of Everest. Because Miranda has such low gravity, if you were to jump from the top of Verona Rupes, you would fall for over 10 minutes before hitting the bottom. Under the ocean hypothesis, Verona Rupes is a massive fault block. It is a piece of the crust that shattered and tilted as the Moon's interior expanded or contracted. It stands as a monument to the violent forces that a subsurface ocean can unleash on a solid shell. Now, we have to ask the critical question: is the ocean still there? The study suggests that the ocean existed between 100 and 500 million years ago. But is it there today, or has it frozen solid? The answer is a tantalizing maybe. Conventional wisdom holds that once the orbital resonance with Ariel broke, which it eventually did, the tidal heating would have stopped. Without that heat source, Miranda should have frozen solid. However, the researchers found a critical clue suggesting otherwise. It is the absence of expansion cracks. We know that when water freezes into ice, it expands. If Miranda's ocean had frozen completely solid, that global expansion would have ripped the surface apart in a very specific pattern of expansion fractures. But when the team did their detailed mapping, they did not find evidence of these specific cracks. This implies that Miranda is still cooling. It suggests that a remnant ocean may still exist beneath the shell. It is likely thin, slushy, and probably rich in ammonia. Ammonia acts as a powerful antifreeze, allowing water to stay liquid at much lower temperatures. So Miranda might be a dying ocean world, caught in the final epoch of its liquid history, but it is not yet a frozen corpse. This leads us to the biggest question in planetary science. Could there be life? The phrase subsurface ocean immediately puts Miranda in the conversation with worlds like Europa and Enceladus. While Miranda is not as prime a candidate as Enceladus, which is actively spraying water into space, it occupies a unique niche. It is in the Goldilocks zone of the outer solar system, not in terms of sunlight, but in terms of chemical potential. If the ocean interacts with the rocky core, as the models suggest, there could be hydrothermal vents. On Earth, underwater hot springs provide chemical energy that hosts thriving ecosystems independent of sunlight. The presence of ammonia poses a challenge, as high concentrations can be toxic to life as we know it. However, we cannot rule out exotic biochemistry adapted to such extreme environments. If life ever emerged in Miranda's deep, dark sea, it would currently be facing an existential crisis as the ocean slowly freezes. But the resilience of life in Earth's most extreme environments teaches us never to say impossible. This discovery adds immense weight to the calls for a dedicated mission to Uranus. The Planetary Science Decadal Survey has already listed a Uranus orbiter and probe as a top priority flagship mission. A future orbiter wouldn't just snap pictures. It would use instruments similar to those on the Europa Clipper. Ice-penetrating radar could peer through Miranda's ice shell to directly detect the water-ice boundary. Magnetometers could detect if the ocean is salty. If Miranda has a salty ocean, it will conduct electricity. As Uranus' magnetic field sweeps over the Moon, the ocean would generate a secondary magnetic field that a spacecraft could detect. Gravity science could measure the distribution of mass inside the Moon. Miranda forces us to rethink what it means to be an ocean world. We used to think oceans were rare, restricted to large moons like Europa or Titan. Now we are realizing that oceans might be a standard feature of icy satellite evolution, even for the runts of the litter. The realization that this tiny, scarred moon, floating in the dark nearly 3 billion kilometers from the Sun, could hold a liquid abyss challenges our imagination. Miranda is no longer just a jagged oddity, it is a priority target, a frozen treasure chest waiting to be unlocked. It reminds us that in the exploration of the cosmos, the most unassuming worlds often hide the deepest secrets. Until we return, Miranda hangs in the black sky of Uranus, a silent testament to the power of tidal forces and the enduring mystery of water in the dark. Thank you for listening to this deep dive on G Fun Facts Online. Stay curious.